New data has pinpointed a new, more accurate time for the expected collision between our Milky Way galaxy and the giant neighbouring M31 galaxy in Andromeda. Instead of occurring around 3.7 billion years from now as previously calculated, the new data suggests the impact will occur around 800 million years later, in about 4.5 billion years' time. And rather than a head-on collision, it'll be more of a glancing blow. The new results are based on a detailed examination of data from the European Space Agency's Gaia satellite. As well as studying the stars in our Milky Way galaxy, Gaia's powerful eyes have also been looking beyond and exploring two nearby galaxies, Andromeda M31 and the Triangulum galaxy M33. It examines stellar motions within them and how they'll one day interact both with each other and with the Milky Way. Our Milky Way belongs to a large collection of galaxies known as the Local Group, and along with Andromeda and the Triangulum galaxy, makes up the majority of mass in the group. Astronomers have long suspected that Andromeda will one day collide with the Milky Way, completely reshaping our cosmic neighbourhood. However, the precise three-dimensional movements of the local group of galaxies remains unclear, painting a somewhat uncertain picture of our Milky Way's real future. The study's lead author, Roland van der Merel from the Space Telescope Science Institute in Baltimore, Maryland, says astronomers needed to explore the galaxy's motions in 3 dimensions in order to uncover how they've grown and evolved and what creates and influences their features and behaviours. Van der Merel and colleagues were able to do this by using the second package of high-quality data released by the Gaia spacecraft. Gaia is currently releasing the most precise 3-dimensional map of stars in the nearby universe, and is releasing its data in stages. Previous studies of the local group have combined observations from telescopes including the Hubble Space Telescope and the ground-based Very Long Baseline Array in order to figure out how the orbits of Andromeda and Triangulum have changed over time. The two disc-shaped spiral galaxies are located between 2.5 and 3 million light-years from the Milky Way, and they're close enough to each other that they may be interacting. 2 possibilities have emerged. Either Triangulum's on an incredibly long 6 billion-year orbit around Andromeda and has already fallen into it once, or it's currently on its first infall. Each scenario reflects a different orbital path, and thus a different formation history and future for each galaxy. While Hubble has obtained the sharpest view ever of both Andromeda and Triangulum, Gaia measures the individual position and motion of many of their stars with unprecedented accuracy. The authors combed through the Gaia data to identify thousands of individual stars in both galaxies, and then studied how these stars moved within their galactic homes. The stellar motions measured by Gaia not only reveals how each of the galaxies move through space, but also how each rotates around its own spin axis. By combining existing observations with the new data release from Gaia, the authors were able to determine how Andromeda and Triangulum are each moving across the sky, and they calculated the orbital path for each galaxy both backwards and forwards in time for billions of years. The velocities show M33 cannot be on a long orbit around M31, but is instead making its very first infall into Andromeda. And while both the Milky Way and Andromeda are still destined to collide and merge, both the timing and destructiveness of the interaction are likely to be very different from that previously expected. As Andromeda's motion differs now from what was previously estimated, the galaxy is now more likely to deliver a glancing blow to the Milky Way rather than a head-on collision. And it will happen about 800 million years later than previously anticipated. That's around 4.5 billion years from now, rather than the previously calculated 3.7 billion. The findings are crucial to science's understanding of how galaxies evolve and interact. There are unusual features in both M31 and M33, such as warped streams and trails of gas and stars. But if these galaxies haven't come together before, then these can have been created by gravitational forces felt during a merger. Perhaps they formed through interactions with other galaxies, or perhaps by gas dynamics within the galaxies themselves.